Okay, this is going to be lesson 2 in unit 4 for pre-calculus. Well, we're going to talk a lot about rational graphs today. All right, here's your function. Okay, here's your function. X cubed minus 3x squared minus 4x plus 12 over x squared minus 2x minus 8. Okay, then we will give you the factors here. These are the factors. Okay? So what we're going to find in these problems, okay, we are going to find the vertical asymptote, the horizontal, or the slant asymptote. We're going to find the whole, the x-intercept, the y-intercept, the domain, and the range. Okay? All right, now, a couple things. Whatever eliminates, okay, this is the removable discontinuity. Okay? So the removable, or the whole, is at x equals -2. Okay? All right? So what we're left with, okay, is we got x minus 3 up top, x minus 2, x minus 4 in the bottom. Okay? Now, in this case, my vertical asymptote is the solution of the denominator, which will be x equals 4. Okay? We have to decide is, do we have a horizontal or a slant? In this case, we have a slant asymptote. Okay? How do I know that? All right? I know that because the denominator is bigger than the numerator. So what I'm going to do is I am going to do long division. I got x cubed minus 3x squared minus 4x plus 12. I am dividing by x squared minus 2x minus 8. Okay, as we remember, we went over in long division. We want to get rid of this first term. That would just be an x. So x times that would be x cubed. X times that would be -2x squared. That times that would be -8x. Remember, we are subtracting. Okay, so subtract. This turns into a positive. Subtract. That turns into a positive. So I got -1x squared. Okay, positive 4x plus 12. All right. In order to get that, I would have a -1 in there. Okay. All right. So that would be -1x squared, positive 2x, and positive 8. Okay, we're subtracting, so that goes away. Okay, 4 minus 2 would be 2x, 12 minus that would be 4. Okay, and that's what we worked on, and that's got that part over it. Now, the only part that really matters for us is this first part, this x minus 1. Okay. That y equals x minus 1 will be our slant asymptote. All right? Now, what I can do to help me find the x-intercept and y-intercept is I can go ahead and graph this. So I'm going to go to graph, okay? And I'm going to put the original in, x cubed, okay, minus 3x squared, all right, minus 4x plus 12 divided by x squared minus 2x minus 8. And draw it. Okay. Might have to zoom out maybe one time so I can see it. Okay. All right, this is what it looks like. Now, I'm going to do g-solve, root. I got an x-intercept at 2. Let's see if there's any other ones. An x-intercept at 3. So I got an x-intercept at 2 and an x-intercept at 3. Let's check my y-intercept. G-solve y-intercept. A y-intercept at y equals -1.5. The other thing we're going to want to find here for this shape when we have the slant is we want to do g-solve max. My max, this will matter in a little bit, 2.5, 0.17. And then g-solve minimum, I got 5.4, 5.8. Okay? Now, look at where those points are. Okay? All right, so I'm going to go ahead and plot some of this stuff, and I'm going to leave this graph up. okay, a vertical asymptote at 4. That would be here. How would I graph y equals x minus 1? Okay, that would be a y-intercept of -1, a slope of 1. So I'm going up 1 over 1, okay? And so what this would look like is this, okay? I'll get to the hole in a second. An x-intercept at 2, an x-intercept at 3, a y-intercept at -1.5, and now here's where this comes back in play. 2.5 over, 0.7 up. So this is what it looks like. All right. I would also graph this 5.4 over, 5.8 up. So that'd be my other point, and this is what this part looks like. Okay? So there's my graph. Now, let's talk about the domain. Okay, we did this before in the last unit. The domain would be x is an element of all real numbers. X can't be a couple things. It can't be -2. It can't be 4. Okay? If you want to use interval notation, you can. Okay? Now, let's talk about this hole. At x equals -2, that would be here. So on my graph, I want to put a hole, all right, at where that would be on the curve, okay? The range. If you notice here, I've got two parabolas, okay? One that's going this way, okay? So this one here, all right, there'll be y is an element of all real numbers, okay? This would be y is less than or equal to. In that case, that number is the 0.17. This one is going up, so that's going to be y is greater than the 5.8. Remember, this is x, y, x, y. So if I was doing interval notation here on a number line, that's 0.17, 5.8, okay? So it would look like this, okay? Well, what would that look like interval notation-wise? -infinity, okay, to 0.17, close bracket, union, close bracket, 5.8 to infinity, okay? All right, and that's what my answer would be. Let's do another one here. If my board will cooperate, okay? Let's say I've got, my function is x cubed minus 2x squared minus 16x plus 32, all divided by x squared minus 7x plus 10. That's going to factor to x minus 4, x plus 4, x minus 2, all over x minus 2, x minus 5. Okay? So we're going to find some things here. We're going to find the vertical asymptote, the horizontal asymptote, or the slant. Okay, we're going to find the hole if there is one. We're going to find the x-intercept, the y-intercept, the domain, and the range. Okay? Now, I've got a removable here. Okay? So that would be, the hole is going to be at x equals 2. Okay? What's left over? Underneath the bottom, I'm going to have a vertical asymptote at x equals 5. Okay? Do I have a horizontal or slant? I've got a higher power left in the numerator, so I'm going to have a slant asymptote. So I'm going to do the division here. Okay? X cubed minus 2x squared minus 16x plus 32 divided by x squared minus 7x plus 10. Okay? I would need this eliminated, so that's x cubed, all right, minus 7x squared, okay, plus 10x. Okay? All right? Remember, I'm doing subtraction. Okay, so that turns into a plus. That'd be 5x squared minus 26x plus 32. Okay, so what would I have here? Okay, I would need this to be plus 5. So that's going to be 5x squared minus 35x. All right, plus 50. All right, once again, subtraction. Okay, that would turn into 9x, and that would turn into negative 18. So that would be the remainder. Okay, all right, 9x minus 18 over my x squared minus 7x plus 10. Now, the only part that matters for me is the slant is y equals x plus 5. Okay, so how am I going to graph that? 5, okay, up 1 over 1. Okay, so here is what my slant asymptote looks like. All right, this isn't a very good graph. Let's see if I can't move that. Okay. Whoops. Maybe I can. Okay. All right. This one, a vertical here. Okay. All right. Sorry. Okay. We'll get to the hole and all that kind of stuff in a second. What I want to do is I want to go ahead and graph this. Okay. I got, let me move this back up. Hold on. All right, there we go. What does that have to deal with it? I'll have to show you from the other side. Okay, let's go ahead and graph this at x cubed minus 2x squared minus 16x plus 32 divided by x squared minus 7x plus 10. All right, draw. Okay, as you can see, I can't see that, so I might have to zoom out. Okay, you can start to see it there. Okay, so here was my other asymptote. It goes off into that corner. Okay, so don't have a great picture here. All right, let's see if I can find some of the stuff. G solve root x equals -4. Let's see if there's any others. Okay, I got x equals 4. Okay, so I got let's see here. Yeah, this slant is more like here. Let me fix this. My vertical was here, that's fine. Okay. Yeah, that's better. Okay, and I'll just erase this little part here, because I don't need that. That's fine. Okay. So I got an x-intercept at -4 here. Okay, another one at 4. Okay. G solve y-intercept at 3.2 would be here. Okay. I also want to look at, with both of these are minimums and maximums. G solve max. Okay, my maximum is basically 2, 4. Okay, so 2 over 4 up. Okay, so this is what this picture would look like. Okay, keeping in mind, okay, all right, keeping in mind that I have a hole at x equals 2, so about right here. Okay, all right. Then I want to do G solve minimum. That's going to be 8, 16. Okay, so as you can see, 4, 5, 6, 7, 8. It's way up here, and my picture would go something like this. Okay, it's not a great example. Okay, all right. My y-intercept was, what was my y-intercept? 3.2. Okay. Now, my domain would be all real numbers. X can't be 2. X can't be 5. My range, I got 2 situations going on. I got something less than 4, okay, because it's at the hole, it's actually at the whole part. And then I got something where it's greater than or equal to 16. So what does that look like? The range would be -infinity to 4, union 16 to infinity, okay? Not the best of examples, but I think you're starting to get the idea, okay? Let's do one more together. Okay, let's do one more together. Let's say I had y equals 2x minus 3, x minus 2 over x minus 2 and x plus 6. Okay, all right. So what would happen here? This would eliminate. I'm going to find the vertical asymptote, the horizontal asymptote or the slant, the whole, the x-intercept, the y-intercept, the domain, and the range. Okay. Now, the elimination of the whole would be at x equals 2. My vertical asymptote is the solving of that, which would be x equals negative 6. Now, what I have left over is I have this. Okay? And this is going to be a tie. So what I would do to figure out the horizontal, I would divide those two. 2 divided by 1 would just be 2. There is no slant here. So what I would have as a graph is this would go this way. Okay? This will go this way. All right? I simply would do 2x minus 3, all right, divided by x plus 6 that's left over. Okay, G solve root. I've got an x-intercept at 1.5. Oh, I put the vertical asymptote in the wrong place, didn't I? Hold on, sorry. At 1.5, I think that's the only one. G solve y-intercept at negative 0.5. Okay, this graph looks like this. Okay, my whole is at 2, so at 2 on the graph, I would just put a little open circle right there. All right, let's find the domain. Pretty easy on this one. All right, x is an element of all real numbers such that x can't be 2 and x can't be negative 6. The range, now this is different, okay, all right. The full graph is in play here, so this would be all real numbers except y can't be 2, okay. This is very similar to the ones, all right, that we have done in the past, all right. So here are the problems that I would like you guys to work on, okay? I would like you to try this question. Which basically is x minus 1, x minus 3, x plus 3, all over x plus 3, x minus 5. I'd like you to do that one. I would like you to do this one. Okay. I would like you to do this one. I want you to try to factor that one first. Okay, so what I would like you to do is make a graph, okay, find the vertical asymptote, the horizontal asymptote, the whole if there is one, or the slant, the x-intercept, the y-intercept, okay, and the domain and range. Okay, all right, so go ahead and pause your video and go ahead and do those. Okay, all right, I'm going to try to do this real quick. Okay, what would happen on that first one? Is that we'd have an elimination there. Let's put vertical asymptote, horizontal asymptote, or slant, whole, x-intercept, y-intercept, domain, range. Okay, so my whole would be at x equals -3. I'd be left with the scenario of x minus 1, x minus 3 up top, with x minus 5 in the bottom, if you prefer. All right, so that's going to be our slant. Okay, so the original is this. Okay, so what I would want to do is I would want to do the division here. Okay, x squared minus 2x minus 5. I would need that to be x. Okay, I'm sorry, minus 15. I need that to be x, so that's x cubed minus 2x squared minus 15x. Okay, subtract turns that into positive, subtract turns that into positive. So that's 1x squared, 6x plus 9. Okay, all right, and so this would have to be a plus 1 there to get the 1x minus 2x minus 15. Okay, that turns into 8x, that turns into 24. Okay, over that. Okay, so what really matters there is the x plus 1. What's left over in the bottom is x equals 5. Okay, how I would graph that. X cubed minus 1x squared minus 9x plus 9 divided by x squared minus 2x minus 5. Draw. Okay, sort of crazy graph. Oh, not minus 5, minus 15. Okay, there we go. So G solve root, I got x equals 1. Okay, G solve G solve root 1 and 3. All right, G solve y-intercept, y equals -0.6. Okay, to get the domain with this, I got that double. I'm going to do G solve max. My max is 2.7.34. G solve minimum 7.8, 11.6. Okay, all right. So from the domain standpoint, it's all real numbers, but x can't be -3. X can't be 5, okay? All right, the range, okay? All right, as you can see, I've got this going down, so it's gonna be less than or equal to 0.34. It's gonna be greater than or equal to 11.6. So that's going to be -infinity to 0.34, close bracket, union, close bracket, 11.6 to infinity. Okay, all right, I think you guys can plot out the points. Okay, let me just go ahead and finish up with one of those other questions. Let me do 8x squared. 8x squared plus 18x minus 5, and 2x squared plus 7x plus 5. If you factor that, that's 4x minus 1, 2x plus 5, 2x plus 5, x plus 1. Okay. So my whole would be at x equals negative, basically 2.5, okay? The situation I have here is 4x minus 1 over x plus 1. That's going to be a horizontal asymptote at y equals 4, okay, because I divide those. My vertical asymptote is going to be this part, which would be x equals -1, okay? X-intercept, y-intercept, domain, and range, okay? I already know the domain, all real numbers. X can't be -1, x can't be -2.5, all right? That's easy, all right? Let's get the x-intercept, y-intercept, okay? So I got 4x minus 1 divided by x plus 1. Draw, it's one of those different ones there, okay? So G solve root is y equals 0.25. sorry, that was the y-intercept, sorry. That's x equals 0.25. Let's see if there's any others. Nope. G solve y-intercept, y is -1. Okay. Now, since I have a graph that looks like this, okay, all I got to care about is the horizontal asymptote. Okay, so the element of all real numbers, but y can't be 4. Okay. All right. If you wanted to graph that, you could relatively easily. Horizontal, vertical, okay, x-intercept here at 0.25, y-intercept at -1, okay, looks like that, and like this, okay. Where's the hole at -2.5? So this is -2, -2.5, just put the little hole on there, and you have your graph. All right, my video is running a little long. I don't have time to go over the other one. It's done very similarly to this one.